All right, welcome everybody. Let's get to the lesson. Here we're going to be expanding our ideas and trying to go deeper within the power rule, right? So what do we mean by the power rule? We're taking the derivative of some original function. We've been practicing this a lot in class lately, and this should feel easy money. So here, if we had some 5x to the fourth minus 3x cubed minus 2x squared minus 7x plus 8, what is the derivative of this function? Right? Take a second and you should be able to do this in your head almost, right? What do we do? So 4 times 5 is 20, 20x to the 3 minus 9x squared minus 4x minus 7, and the derivative of any constant is 0. So bam, that's it. Congratulations. But you see here, it can't be this easy in calculus, right? We gotta spice it up a little bit. So here the idea is, for this lesson, how do we find the derivative of some sort of function with a radical, the cubic root, and all this kind of jazz. So here, how do we actually find the derivative of this type of function? Okay. Here, based on the previous lesson that we just did over here, let me find the notes for it. The video that you just watched before, hold on. Here, what did we do? Study. Yeah, here we learned about how to convert radical form into some exponential form. So the question I have for you here first is, can we express this as some exponential form, this square root of x? This square root of x will also be equal to x to some fractional exponent. What would it be? Right? It should be x to the 1/2, right? Just like we showed in the previous video, right? So now here, if we wanted to take the derivative of x to the 1/2, we're still using that rule where we multiply the exponent to the constant. So just like we did before, 4 times 5 is 20, then the 4 minus 1. So what are we going to do here? We're going to do 1/2. See, notice that this 1/2 multiplies to, what's the coefficient here is a 1. So it's going to just be 1/2 times, now what do we do with our exponent? It's going to be x to the 1/2 minus 1. Just like we did over here. Just like how we did 4 times 5 was 20. We did that here, right? We did 1/2 times 1 is 1/2. And the same way we did 4 minus 1 is 3, we're just going to take 1/2 minus 1. And that's how we kind of continue here to find the derivative. So here we just have to get used to the idea of fraction. So notice that this 1/2 stays the same. Now this is just take your algebra. What is 1/2 minus 1? Notice that 1 is still equal to 2 over 2. So we're going to express this 1 as 2 over 2. So we have 1/2 minus 2 over 2. And why did we express it as 2 over 2? Because when we're subtracting exponents, we want the exponents to have the same denominator. So notice that what happens to the denominator? The denominator stays the same, and 1 minus 2 is -1. So now we just have x to the -1/2. So because 1/2 minus 1 is -1/2. But now here, it's not in simplest form because we have a negative exponent. So we need to have positive exponents. So how can we continue? What happens when we have some negative exponent? Just like we had before in the previous video, let me go back in time. Don't you remember if we had some 8 to the -1, what did we do? It was 1 over 8 to the 1. If we had 8 to the -2, it is 1 over 8 to the 2. So then trust yourself, what will this become? It's equal to, so this 1/2 stays the same, times 1 over x to the 1/2. Notice how this x to the minus 1/2 becomes 1 over x to the 1/2, which equals, notice 1 times 1 is 1, then this will be 2, but hey, what is x to the 1/2? Square root x. And bam, we are done. The derivative of the square root of x is equal to 1 over 2 square root x. All right? So let's just review. Very quick review. First, what did we do? We converted this radical form into some exponential form. So this square root of x is really x to the 1/2. Then we just followed our same power rule that we've always been following here. We take this 1/2, multiply it to this constant, which is 1. So 1/2 goes here. And then we're subtracting 1/2 minus 1. And now what is 1/2 minus 1? That's negative 1/2. But notice that we need to make sure that we have positive exponents, and we don't want to leave it in some exponential form. We want to leave it in a radical form. So notice that from x to the negative 1/2, this 1/2 on the outside stayed. This x to the negative 1/2 became 1 over x to the 1/2. And then we multiplied the 2. 1 times 1 on top is 1. 2 times, but x to the 1/2 is what? Square root of x. So you're doing 2 times square root of x. Listo. Not easy. Well, not that it's not easy. It takes a little bit of practice. So notice that for the first question, we did square root of x. Let's look at the next question for us. What if we said, if this is y is equal to the cubic root of x, what is dy dx? Or what is the derivative of y? Right? So the same kind of technique that we did here, let me zoom out a little bit. The same technique that we did here, try it for this question here on your own. Don't be afraid to make mistakes. Right? First, can we express this radical form into some exponential form? Notice that the square root of x was x to the 1/2. What would the cubic root of x be? It's equal to x to the 1 over 3. Okay? Then what do? Same, follow the power rule. 1/3 goes here, so it's 1/3 times x to the 1/3 minus 1. But what is 1/3 minus 1? Notice that 1 is equal to, before we had it as 2 over 2, what are we going to have it here? As 3 over 3, so we could subtract this, right? So this is 1 over 3 minus 3 over 3, which is equal to negative 2 over 3. Because notice that the denominators are the same, and we're just doing 1 minus 3. So, okay, not too bad. So now we just have 1/3 x to the negative 2 over 3. Let me zoom in. Now what I want, the same way we went from here to here, take your time to go from here to here. Be patient. Don't just unpause and let me do it. Try and do it on your own. And hopefully we remember from the previous video what we do when we have a 2 over 3. When we have some number on that outside here, right? So this will equal what? 1/3 times 1 over x to the 2 over 3. But that's still the same as 1/3 times 1 over. Now, how do you convert this into some radical form? This should be cubic root of x squared. Because don't you remember, you can, the denominator goes on the outside of the radical, and the numerator goes on the inside of the radical, over here with this x here. So then that just becomes 1 over 3 times the cubic root of x squared. And that's it. This represents the derivative of this function. This is y. This is my dy dx, is right here. Okay? These take some practice. If you want, try and do it for the 4th root of x on your own. And what should the answer be? You should get, what should you get? You should get 1 over 4th root of x cubed. And there's a little pattern to it. But that should be what you get, but try and do it on your own. Okay, let's look at another problem together. Not this one. Let's take a look at this one. Oh, they're gonna get a little bit more difficult. Now here, for this type of question, this is a little tricky. There's something that I need to show you that will take just a quick little second, but we have to look at, one second. To do a question like this, we need a little ninja move. And what is the ninja move I'm talking about? There's another way to look at the power rule. So you're so used to doing this, where, okay, if I said, hey, find the derivative of 5x to the fourth, you're used to doing, okay, 4 times 5 is 20, then 4 minus 1 is 3, so this is just 20x to the 3. And you're correct. Another way of looking at this, though, is, if I said find the derivative, you're allowed to, this is the ninja move. You take the 5, bring it to the side. So notice that this 5 is here, times, now all we're going to do is just take the derivative of this x to the fourth. What is the derivative of x to the fourth? It is 4x cubed. But then what do you do with that 5? You got to bring the 5 back inside. 5 times 4 is 20x to the 3. And notice that this is the same way. Right? So what you're allowed to do is take this constant out, pull it to the side, and then multiply it back in when you're done. Now watch how this technique will help us for the next problem. Because here, if I said, okay, 2 over 3 times the square root of x, this is the same as 2 over 3 times 1 over square root x. So the same way that I brought this 5 on the outside, and then I'll bring it back in, I'm going to take this 2 over 3 and bring it on the outside for now. So I'm just going to bring it on the outside. But here, this is a little tricky because we have to take 1 over the square root of x and express it as some exponential form. How would you do that? Hint, what was the square root of x equal to? We just did it before in the first example. What was square root of x equal to? Go find it. What was it equal to? It was x to the 1/2. Right? So notice that x to the 1/2 is equal to the square root of x. But what would 1 over the square root of x be? Well, it is equal to 1 over x to the 1/2. But there's a little trick you can do to express it just as one single term, as x to the negative 1 over half. Now that's being very sneaky. This 1 over square root x is the same as x to the negative 1/2, because we know that x to the 1/2 is the square root of x, but making it negative puts it on the bottom of the denominator here. So notice this is what we need to do. So now here we're just taking 2 over 3 times x to the negative 1/2. Now what I want you to do is just the same way that we took the 5 and we brought it out and we just took the derivative of this. Take this 2 over 3, ignore it for now, take the derivative of this, and then you multiply the 2 over 3 back in. Take your time, don't be afraid to make mistakes. What would happen here? So if you want to take the derivative of just x to the negative 1/2, it would be 2 over 3 times negative 1/2, because we're multiplying this over here, right? This is negative 1/2 times x to the negative 1/2 minus 1. But then this becomes what? 2 over 3 times that negative 1/2, right? So I'll say negative 1/2 times x to the negative 3 over 2. Because what is negative 1/2 minus 1? That's negative 2 over 2, and negative 1 minus 2 is negative 3 over 2. And that's what we have here. And then what happens here, okay, now we're going to bring that 2 over 3 back in. So here, 2 over 3 times negative 1/2 is negative 2 over 6. And this x to the negative 3 over 2 is also 1 over x to the 3 over 2. Right? We're converting this x to the negative 3 over 2 as 1 over x to the 3 over 2. But then that's equal to negative 2 over 6 times 1 over square root of x cubed. So then that equals negative 2 over 6 times x cubed. Woo! Woo, woo, woo. Not easy. Very, very tricky. Very tricky. Let's just review, right? Here, what was the first move? We took the 2 over 3, let's just bring it to the side, right? So then we're just left with 1 over square root x. But this 1 over square root x, we know square root of x is x to the 1/2. So 1 over square root of x is x to the negative 1/2. So now we're just taking the derivative of this. Okay, so you put this over here. Now you take the derivative. So this negative 1/2, you bring it down here, okay? Then you have to subtract 1. So negative 1/2 minus 1 will become negative 3 over 2. Now, let's multiply these, let's bring that 2 over 3 back in. So you multiply these two fractions, you get negative 2 over 6. And then you just have to convert this x to the negative 3 over 2 back to some radical form, right? So then here, this negative 3 over 2 is 1 over x to the 3 over 2. And notice that, remember, the denominator goes on the outside, the numerator goes on the inside, and then bam. Negative 2 times 1 is on top, 6 over here, and that's it. Not easy. I think in a different video, I'll pause and I will do these two questions. Or if you want, try and do this question on your own and try and do this question on your own. I'll do it in a separate video because I feel like it's probably a lot. I'll see you.